Hello guys, this is Am and welcome to the channel. In this video, let us look at an interesting interview question based on recursive programming. If you haven't watched my previous video on recursive programming, I highly recommend you to watch it. I'll link in the description below or somewhere here so you can navigate it to very easily. So now, the programming question is, from the given collection of numbers, find all the possible expression which evaluates to the given target. The valid operators are plus, minus and multiplication. So these are the quick examples. Notice that we are even considering the expressions which are just subset of the given numbers. So let us think first. We have to calculate all the valid expressions, right? So we have to visit all the expressions which are possible. And also at any given point of time we have three options: plus, minus and multiplication. We have to consider that as well. So hell a lot of checks, right? As I've mentioned in the previous video, in recursion we can write some elegant pieces of code. But if you want to write the same piece of code using loops or iterative programming, all the best, because in iterative programming you have to keep track of various variables. So let us look at the solution for this problem. Any recursive program can be visualized using a recursion tree. It is the best way to visualize a recursion program. So let's see the solution to the problem. The operators given are all binary, so we have to first consider the two operators from the collection. From the example, the first two operators will be 1 and 2. So the starting node will be the start node in our example, and the three options are we can perform addition, multiplication or subtraction from the given two elements. So let us have those. So let us evaluate from left to right. 1 plus 2 is 3. That is not equal to the target. So we have the position variable which holds the index on the collection. So the position variable will be 1. So from 1 plus 2 we have to call the function again. So do we have the element in the collection? Yes, we do. So we have 3 in that position. Let's add it to our expression, and by the way we have 3 options again. So we have to add all the 3 possible expressions. Those are 1 plus 2 plus 3, 1 plus 2 minus 3 and 1 plus 2 into 3. These are the possible expressions from there. So let's evaluate from the left to right again. 1 plus 2 plus 3 gives us 6, and that is equal to the target. And yes, we found a solution and we are printing on the console. Good, kudos. But let's move into the recursion and let's increment the position, and it's 4. Do we have the element in the collection? No. So we have reached the end of the collection, and thus that is nothing but the base case in the problem. So if we reach the end of the collection, we just return. So we have actually visualized all the left branch, the leftmost branch of the recursion tree. And if you may observe, all the checks we are doing are exactly identical to every node. That is why recursion is very effective and very natural in this problem. So let's move on. The next expression is 1 plus 2 minus 3. It doesn't give us the target, and we again check if we have an element left in the collection. No, so we just backtrack, and we have another expression 1 plus 2 into 3, and which doesn't give the target value, so we just backtrack it again, and thereby we have finished the left branch. And then leave the explanation here because it becomes very repetitive and redundant, and I'm sure you may have got the whole concept of this, right? So this is the final recursion tree which will be created at end of the program. As you know, there are two possible expressions. Those are 1 plus 2 plus 3 and 1 into 2 into 3, and that is the solution to the problem. So now let us look at the program. And I was talking how elegant the recursive program can be. So this is the Python code for the program.
So this is the function which is used to print all the given expressions. So we are taking 3 parameters. One is the position that we have talked in the explanation. The current value holds the evaluated expression value, and the expression is a expression itself. These two are the base cases here. One is at any given point, if the current value is equal to the target, we print the expression and we just return. Or else, as we have talked in explanation, as if the position value is equal to the length of the collection, here the collection has the inputs 1, 2 and 3 and the target is 6. So if it reaches the end of the collection, we check first if it is equal to the target. If it is, then we print the expression, else no. But these two are the base cases. But the first time if we call it, let's say we are calling it this function for the first time. So position will be 0, so because the default parameter is 0 here, and the current part will be 1. As the operators are binary, we do not perform any operation on the first element we take from the collection. So if we check if the index we are looking at on the collection is 0, we just increment the position and we pass the current value as 1 and the expression as the string form of the current part, that is nothing but 1. But the second time the expression here will be 1. So first we check if the current value is equal to the target. Now the current value will be 1, so it is not equal to the target, and then again we check with this, the position variable will be 1 here, so we again skip this condition and we get to this line 34. Element at 1 is 2. So as position is not equal to 0 here, we go into the else case and call the recursion functions again. So we increment the position and we add the current value to the current part, that is nothing but 1 plus 2 is 3. Then we add appropriate expression here, as we have done for the plus, minus and the multiplication. So now let's run this and check if we are getting the right values or not. Yes, as you can see, we are getting two expressions. One is 1 plus 2 plus 3 and 1 into 2 into 3. That's all for today's video, guys. I hope you liked it. If you have liked it, please press that like button and share the video. And I'll see you in the next video.